My Radial 12 cylinder opposed piston engine concept. I actually have several of them on my YouTube, but I realized I don't label things well, and a lot of them are on audio blogs and stuff. So maybe this one will, pique the interest of someone. Anyways, uh, let's see here. So the basic concept starts off with opposed pistons, obviously more efficient, but of course there's more heat, and of course there's more friction, of course more wear, and all this other stuff, right? It's like, well, why would you do it then? Why would you? What would be the why specifically? Can you please give me a reason? And the answer is more power, baby. I want more power in a smaller package. I need efficiency to go way higher, and I need power to go much higher. All right. And it's like, that's not what you'll get with an opposed piston, right? And it's like, no, that's actually it's just an opposed piston. You'll absolutely get more torque. I'm going to move on to, but I'm not done yet. An opposed piston, three combustion chamber. Now, three combustion chamber is another version of something that's a single cylinder on my YouTube channel already. It's called the 3 anyways, three combustion. It's literally a number and some letters that mean three combustion chamber per cylinder. Three combustion chambers. And it's like, yeah, center and outside. I seal off the top and bottom. But it's like they're not really a top and bottom. They're just two halves, technically speaking, of a cylinder. Ends. Two. Anyways, point is not halves, ends. They're the two ends of a cylinder that is hollow. That it's the impression of something that's there, and still it does a lot of work. Surprisingly, when you stick something in the hole and then you make it move. It's another joke for quantum physics stuff for virtual particles. Whole thing. It's like, look, the cylinder isn't there. It's a virtual particle. Are you sure? It's pretty sure it's there. Anyways, point is, getting off topic. So the outsides and the center all combust. It's a 4-stroke, 2-stroke scavenge, single stroke, all that. But that's based upon injectors, and that's based upon the rotating valves. Okay, I have valves that rotate around the cylinders. Those also provide, based upon the ring and its gearing, which can change because there's a different gear, as it can alter its gearing ratio to be such that it slides a little closer towards very dead center to the valve opening. So let's say it's the nozzle that's on the cylinder sidewall. Well, the valve can slide closer to dead center like a valve lift. Exposes more of the nozzle, right? You can also decide to hang around for a little while longer because that's gearing. Gearing ratio means during the moment when the valve needs to be there and open and present, it stays open and present for the entire duration of the intake stroke. Or, for this other one, this one's, well, not the other one, still the same one. It's a direct injection type of technology, which then just turns it into, well, gas and air are both able to be directly injected. And then Sparky McMark boomity booms happen. Which then turns it into fooms out the tailpipe. Anyways, they're like, well, it's gotta be air cooled. I don't want to really just air. I mean, it's just hybrid liquid air cool for what it's worth. Which effectively means, like, yes, we do have cooling fins, but they're hollow, and I put liquid that is a low pressure liquid that is readily willing to turn into a gas, and then during the phase change, it then expends its energy off into the fins and then cools itself. I then was not finished yet because I was like, behold, radiator. Behind the engine, because screw this noise. In front, you want it in front? That's where the fresh. I'm already cooling the engine. I just need to cool it a little bit more. Just put it off to the sides, or something. I don't give a fuck. Well, who says I have to put it in the fucking front? It's weird. Anyways, so now I have 12 of them, 12 cylinders, of course. It's like, how do you get 12 cylinders on a single fucking crank? I'm like, yeah. That one took a while to figure out. I'm not even gonna lie. I have several different videos, like of me going over multiple reiterations of like crankshaft design, because like master connecting rod and all this, and I'm like, I hate this thing. It's not bad for balance, but I hate it. It doesn't make multiple packs go off at once. I want a pack of three, but it's actually it's three and it's for the centers, and then it's six for the outsides because divide that number three. In no way you actually multiply it by two, and then you actually get six, which is the correct number. Because that's how a post piston works when you time it with a four-stroke. I know, sucks. I'm going nowhere, right? But it's like, no. It actually matters because it's like, you see, that piston up there has to be connected to something. And that one was a little difficult to figure out for a while until I was all like, no, it's not. We've already figured this out. We already have a way to like pivot this. I already described basically this for the corrections of the world best, like describing the axle and connection stuff. Anti-gyroscopic inline four engine that actually has, pistons that go from the top down to the bottom and from the bottom that go up towards the top for combustion chambers at the top and combustion chambers at the bottom, and how that would connect together and be timed. So I was like, well, yeah, no, I mean, this is how to run those gearing and then effectively sliding, but instead of sliding, it's a pivot, really. See, as it moves up, that's the piston, right? It perfectly dead center straight, right? But then it pivots. It's got a hinge, which is essentially a wrist pin, but it's actually called an elbow pin because on the other side of the sealed top and bottom header bottomer thing or cider or outside. I don't give a fuck. Point is the seals. Then it goes into the crank, which is the outside, right? But it's like, well, pivot, huh? It's like, yeah, pretty much. That's all you got to do. It's called a pivot, a lever. Turns out like if it rotates one, pivots like that, and then it'll rotate around a given circle pretty consistently, and then that can go into an axle, like a gearing of sorts to a crank gear axle. And then I was all like, behold, the center and the outside are fully 100% finished. That's right. They pivot, and because you think that's not very long, probably, and you're correct. If you don't, you think it's going to be a huge pivot angle and all this, you're wrong. Don't talk. You should probably change what you do as a profession if it's anything to do with engineering. If it's not, then you should probably stick with that because that's your day job and that's good. But yes, no, it won't actually, as a very low amount, because of course we have the ability to bend metal and then have it pivot from a Y center point connection moment, which is otherwise known as take your two fingers, stick them to a bent arced rod, and then where the knuckles are for the two fingers are sticking up and splayed out. That's the center pivot point. Quite strong an arch in two connection points to the arch. Creates a triangle of sorts. Some people say that's a really strong geometric shape. Anyways, it also makes it incredibly short. Along with, shockingly, because it's pivoting at that angle, right? That means it can rotate a given type of ovalesque. Anyways, point is, ovaloidal, elliptical, whatever shape that effectively means rotation to a given crank. It can go up and it can go back down, and maybe that's a gear, perhaps? Shockingly, it's a rotating gear, kind of like a differential conical gear, to a axle that'll allow for it to rotate like that and be constantly connected in a very strong part of this thing called the cylinder engine block, acting also like a pump. By the way, you remember the piston head with the rod and whatever? It's hollow. I always use hollow. I pump in oil one direction, it sucks it in as it goes in, and then that's a check valve apparently, otherwise known as a one-way valve, doesn't really matter. Point is, on one side it goes that way, and then it goes up to the piston head, and then it has an oil ring, you know what I mean? You don't really necessarily need it, but you need some amount of oil cooling, because yo, bro, yeah, you do. It's gonna matter, you need some freaking lubricant, are you kidding me? So anyways, goes off to that. It has some holes in there. Squirts off some oil, and then it goes up back as it then gets flung upwards with the explosions of the combustion cycle. That then shoots oil up, which is actually a good thing because, yo, bro, oil pump. Because another one-way check valve there. You know what I mean? Now I have an oil pump for 12, which is actually technically 24, which I don't technically really need the amount of piston skirt, so if you think I can't get, so much goddamn, oh my god, space given back to me, because look at this tiny little connection rod, you know what I mean? But it's not really, because it's just a piston with a rod, but there's no wrist pin, because you don't need a wrist pin. Anyways, that really just means I only need it to be a certain size and shape. It can be quite thin because it's cooled. It can be hollow. You're gonna have a little bit of structure in it to help the whole thing, and now it's a lot stronger and stiffer and lighter than it normally would have been, which means it revs quite fast. It means I have much less friction as well. Now, the top and bottom I've described multiple times in so many videos I keep forgetting that a lot of people might not know how to do this. They're piston rings. Compression and oil for the connection rod to go through. That's called gapping and some tapering. That way it seals at the right moments when you need it to. Oh no, it's impossible to do it, apparently. I have these round circular piston rings. You can use those for this? And what about that oil ring? You got oil? Do you have any linear actuator oil rings for high pressure and high velocity? Many times a second kind of things, high oscillational frequency, blah blahs. We do actually have those, and they're quite fairly cheap. Yo, Well, there you go. I suppose we'll just use those instead of the new piston ring idea, I guess. Oh, wait, it's not very new. We've used it, like, forever? Instead of on the connection rod, though, they're in the hole of the header and bottomer. Crazy idea and thought process, right? Meanwhile, remember the pivoting thing? You remember that? Right? Yeah, it's a nice little axle and everything, right? Remember the bottom doing the same thing. The central point is the same thing. It's another pivot, but this one just rotates, right? With the little elbow and everything, right? Yeah. Okay, so behold, that connects to the rotating, like your bearing journals. You know what I mean? On your regular connection rods. And your fucking engines. You click, clickety click with the torqueys, and then they move. Right? They got fresh oil all the time. They come in a couple of pieces. Last time I checked, for engines, and these rotating little valves can absolutely do that. They just have to slide in, be pieced the right way, and then they'll have real bearing. Now, bearing. Anyways, they're like a bearing. You know what I mean? But then they're sealed on one side, and then oil and gas doesn't go and mix together because, of course, how do you seal them? Gapping intolerances called, like, this is the flat part, and then this is the vertical and flat part, which is connected as they slide in, and then that's called a hydraulic bearing with the bearings. As they rotate, then they are cooled with fresh coolant and lubricant, and then they're sealed because, you guessed it, the air and then the rotation with the gapping tolerances means there's no fucking way it can actually get into the air coming in. Like, how do you know? Last time I checked, you have what is this thing called? Valve cover vents for a reason, along with crankcase vents. So why don't you go fuck yourself? Maybe you could figure it out, perhaps. We have sliding valves, we got sliding bearings, we got rotating bearings, we got all these bearings and valve types. I basically just did the same thing you're doing. Put a little bit of material there of the, it's a part of the bearing. And now they just slide. Slide. A Fight Club reference for you. Anyways. So it's good in terms of sealed, right? Which is fine for its worth. But that's the other part of it. It's like, no, it's sealed to the air intake. Right. Where are these direct injectors? Where are these? Where are they? Tell me now. It's like, well, they're okay over there. Calm down. There's in the port. We got the porties of the injector varieties, and then we got the direct injectors. The port's pretty obvious. That's a tube you drill, and then you tap, and you weld, and then you put an injector in. And it's like pores where the valvey thing is, and the flow and direction of the airflow, and then whoosh and mixies and of the combustion. Anyways, we're gonna move on to direct injection. Remember when I talked about those sliding valves and how they can move up and back down because they're in a bearing journal? But it's like, no. I don't think you get it. They're in a multi-piece construction. That means the bearing journal can slide in between two other bearing journals. And then those are two separate bearing journals that connect to each other. Okay? That allows for these two sides on the outside to be static, and this to be a dynamic in the center. That allows for it to go towards the very center and then go a little bit further down or up, depending on where it's at, which closes out the outright size of that nozzle hole. And the duration change and the attack, meaning it opens for scavenge effects a little bit beforehand, which can also be a part of your exhaust. Okay, exhaust can be there and open. Remember the dynamic? There's separate parts. Remember that? Right? They can be next to each other, exhaust a little bit further up or down, depending. Or you can have them as a singular valve, where one side's intake and another's exhaust, and that closes off, and then it waits around while the intake does its thing. Now, granted, because it's getting cooled, it's rotating, it then means you'll never have to worry about it possibly causing any of this detonation or knocking effect. Now, that's gearing, because of course it's attached to the gearing, which is of course attached to the rods and the crank, which means I have variable valve duration, timing, and lift that is dynamically altered thanks to basically a CVT-like system, which means it's about as good as you're going to get without getting into free valve technology. Okay, so that's the best I've got. Now, ports are all just, velocity stacks for what it's worth. They're all rings. I mean it. It's like there's an outside and an inside ring, and then there's effectively like a bunch of cones that are right there. Yeah, that go off and then divide, and then there's little other velocity stacks from where that intake, and then it closes off. It goes off to the next set, which then starts looking like a big amount of swirly spaghetti, right? Except it's not. That's structural swirly spaghetti to you, mister. That's your intake manifold. It's also really super cheap and simple to fucking make that. You can basically just cast it at a really pretty thin aluminum and it'd be really strong, which is great. That also means it constantly has a never ending rotation of air, inertia, mass airflow going into every port, which means it'll always maintain a higher static pressure into the cylinders than normal. But it's like, but wait, I'm not finished. Look at all of these crank of the axle with the geary things. Remember, this is called turbine. You thought I was done. I'm not done. No. Turbine. That's right, turbine. That's a turbine. Why do you because that goes directly into my crank. That's right. It's just another CVT gearing to rotate a certain amount, and then that torque is placed directly into the crank. And then it's like, right. But see here, remember that crank axle with the gears? It's hollow. So, anyways, there's an axle that's in there that's free. That's not free floating. It's floating on bearings, right? Whatever. But point is, that'll rotate an intake, which is shockingly a compressor. And as a result of it being a compressor, it'll run off of the crank, and then this will then take over from the turbine, which then the turbine will then take over and dump its power into the crank. You can get more compact. Woohoo! I have 3 combustion chambers, 12 cylinders, all in one tiny little package. They're right next to each other. They're not staggered. There's no staggering here. Let me tell you. You think there's going to be staggering. There's no staggering. There's nothing behind it. Nope. All in one. That's right. That thing. I'm that guy. Like, look at a clock. That's literally what you're going to be doing for your angles here. But that's perfect for the pivot stuff, for what it's worth, and the fact that I would prefer you to have smaller, smaller, shorter connecting rod links that are perfectly only moving in a primary direction because there is no possibility of having secondary forces, more or less just because they're canceled out by the pivot thing. Okay, so like the pivot thing, they're just opposite. So one will pivot this way, this one will pivot the other, and so they're perfectly balanced. But that also means 9 go off at once. So you're like, there's only these are short, tiny, so few tiny little, look how small these piston heads are. 9 are going off in a pack of 3, 4 times for a total of 12. Because it's actually technically 3, and then 3, and then 3, and then 3, and it's on a 4-stroke, right? But that's the 4-stroke ECU timing. Yeah, no, you didn't think about it, but it's like, no, I could do 2-stroke scavenging. And then it's like, no, I could just inject. Behold, the new technology is a new thing. This is a high-flow nitrogen air filter. It filters out your nitrogens. So you don't want those nitrogens, you want the oxygens. Those nitrogens go off into cooling the cylinder a little bit more. That's the scavenge kind of thing. But also they'll go into the turbine, okay? And then also we're going to soak up some of that heat with nitrogen. We're just blast in some nitrogen, and then that'll just dump off for combustion stroke somewhere else. And that's a 6-stroke, actually, technically. But it's really a 2-stroke. But then nothing actually technically does any of this intaking stroke, even though we do have a manifold there. I was like, the manifold is now really just an air pressure regulator for our direct injectors. That's right. Now, the rotating ring valves are gearing for the injectors to effectively pump more pressure into the injectors themselves. There are storage of oxygen or nitrogen, depending on where and how you want to do it. That also means I can cool it because it's a big surface area, and I can add in some fins, and that's an air-to-air intercooler. I can also water cool the inlet charge after the compressor to the nitrogen high flow filter. I still have to filter that air, but it's what the whole sort of system is about. And the whole thing ultimately accomplishes of a 1-stroke cycle because it's a never ending burn fest essentially into any of the cylinders, as I can combine high amounts of oxygen and very high amounts of very non-leaned out, very rich mixtures of gas, and then I can burn after combustion with oxygen. Now, these injectors are modified to handle those higher temperatures, which can be done, and then they're made to also have a higher pressure, but mostly very high flow, which is why the valves, instead of becoming valves, more or less just turn into pumps. Good old-fashioned injector pumps. They burn like a rocket engine into the cylinder by combining two things that you're going to want to burn. Simple stuff, but that also means they're quite hot, and so usually you don't want to do that. Why would you do it? Well, mostly because we're cooling with nitrogen. Mostly because it's also super cool and will be really powerful and highly efficient. Because as we go into the exhaust, we can continue burning that fuel with a blast of oxygen and then cool it off with a blast of nitrogen. Now, they're the same injector, air injector, which is just gaseous air injector, like a methane, right? But they switch their tank. Oh, it's oxygen over here, that's a valve, and then over here, that's nitrogen. Switching the tank then means I can now push in nitrogen and or oxygen, depending on what I like. Now, this is compressed, filtered through our atmosphere stuff. This is not liquid. This is not in any way what you think it's going to be. Okay? Still, though, highly efficient because, of course, it goes into a turbine and then it dumps it into helping, like a Brayton cycle. But except because now I have the 1-stroke and then 6-stroke combined with a constant thrusting injecting system and a oil-cooled piston and oil and air, liquid and air-cooled hybrid radial is now called the Lemke cycle. Because I'm not even actually finished yet. The exhaust goes into the center and or outside of the next preceding or last currently fired cylinders. That's right. That exhaust, instead of going into the turbine, first must go into another cylinder bank and fill it up. That way it goes such that I don't need a flywheel, kind of like a rotary instead of a radial. I'm massively able to reduce much more of the flywheel necessary to maintain the given continuous combustion of the engine. Gas that goes off into another part of the cylinder is able to reduce the amount of parasitic loss. It maintains a given type of fluid pressure dynamic. That means it uses the torque, but it's not really, because technically it needed torque from a flywheel to push itself back up. So now the flywheel can go lower weight, and then of course the pistons can still go back up because of course there's now gas there. Simple stuff. Think of it as there's a lower pressure because there's an exhaust valve at the top, and if it goes into the bottom of a standard single cylinder, well, there's a lower pressure up there, and now there's a lower pressure here, and it'll try and balance itself up, and conservation of momentum means it'll continue going up. A lower flywheel is necessary to make that happen, and so you get more efficiency. Because it's perfectly vertical or diagonal or any of those things, it now has a way to do that much less frictionally, meaning it has a lot less friction. Right? Great stuff, right? So, as a result, it's called the Lemke cycle because it goes into that and then it'll go into the turbine. It must always go into another exhaust cycle after it has already gone into another cylinder. It always has to go into a turbine. It always needs to have thrust. It always needs to have a six-stroke of a nitrogen, or at the very least, some amount of fluid coming in. Most of my Lemke cycles are thrust, thanks to rocket injectors, or straight up, I'm going to blast in fuel to soak up heat and only burn after top dead center with a little bit of air that's there, like a reversed compression ignition system. You typically want to put fuel in. No, that's not what I want to do. I want to put air in. I have oxygen. I need to burn it very gingerly. I don't want a detonation or an explosion. So, that's why they're always rich as fuck mixtures. The rich gas will soak up the heat. It'll burn a little bit, and then I can force in more air to burn. Otherwise, oxygen, reactive gas. That's why it's a Lemke cycle. Now, granted, this is an advanced Lemke cycle because it's several different types of my Lemke cycles combined together here. Because I have a six-stroke on top of another type of six-stroke, which is the exhaust recycle, into another exhaust recycle with a six-stroke nitrogen exhaust kind of scavenge and heat soak recycle. While I still push in nitrogen to my turbine, while I still push in nitrogen to my exhaust ports, and so on, so that way it remains not melting. Right? But that also means it has a short stroke, even though it'll act like it has a long stroke. That means it's a very easily tunable, perfectly balanced, high as fuck RPM, rotating valve, crazy insane radial engine. That's a 12. 3 combustion opposed piston engine. After describing it to you, this is why I wanted to use it for shocker, tiny little motorcycle. That's right. Tiny little motorcycles. Dude, my thumbs. That's right. I said thumb-sized little tiny pistons. My tiny little thumb pistons. Look at them. They're so small. Alright. If you come back, it is supposed to also be for aircraft. It is also supposed to be for locomotive trains. It is also supposed to be for regular, uh, cars and subcompacts. Okay. But the reason why is because it's like, it's now stupendously easy to make and manufacture and scale. It's got a footprint that's massively smaller than before, which is the whole point of it. Most radials are huge things, and it makes no sense really to go with them, right? But it's like, well, I can shrink this, and the footprint is much smaller, and the amount of output of power is much higher, and the efficiency is much greater, which then has turned it into such that in the 60, maybe even 70% range of efficiency now, with a little bit of air cooling off to the sides, which it's like if an aircraft, that's on the wings, either the leading edge or for the ailerons or something similar. When I can ultimately allow for that to create a, let's say it was a turbuckle or tubulacle or something like that. Well, that's, with the right fin density, which is really just a given surface area with the right kind of, in the line and direction of air travel here, channeling, which is fins as fluid travels through them, kind of like how, birds have blood that travels through all the bones and wings that they've got, the little, and it cools their body, big surface area contact. Anyways, point is, another version of the same thing because it'll re-energize and expand it and create an even greater amount of actual lift because of the fact that it will expand and produce a lower pressure than below, at the top versus bottom. And if you've ever looked at bird wings in flight, you'll notice that most of the blood is mostly pumped at the top of the wing versus the bottom of the wing, towards the leading edge, typically, which is why I tend to do that. Or at the top of where the nose is, the hood, or off to the sides, right? Or, the cabin, right? So make it a little bit more efficient, so to speak. Now, same thing for cars, though. I do the same thing for cars. It's like, hey, this thing that you want called downforce? Yeah, I'm gonna put a skid plate that's not technically a skid plate. It's actually technically a diffuser, but it's actually a diffuser skid plate. See, like there's a skid plate underneath the diffuser, and then like that diffuser is actually the radiator. But then there's a little thing that makes sure called, a filter that rocks and debris doesn't go get caught in that fucker. But it's the same kind of thing that you have for like your front end. But that means I can make the front end far more aerodynamically advantageous for myself. And I still get downforce, and a good amount of the weight is lowered down. And because this is a radial that's quite small, I can get it pretty darn close to the firewall, where their dash is, in between, like where the engine bay and all that is, which means I can push you further up or further back, or I can have it flat right in between, or even have it sideways, you know, such that it's basically sticking into where the transmission would be, making it so you can have a much easier time making a rear wheel drive, otherwise known as, I really just started sticking it into the trunk. Yeah, I know this sounds weird, but a lot of rear-engined cars or mid-rear engine cars that have radials started springing up in a lot of my videos for a reason, because it was like, Well, that's easy as fuck to do. Um, I actually want it to start curving up towards the rear and then have the top start curving down, because that's more teardrop like in terms of its aerodynamic efficiency, and I still get downforce. And then I have the wheels that are wider than where most of the center mass and gravity is, which then gives me better handling and grip, kind of like a better Volkswagen. That's where the teardroppy whale, shape subcompact car came from, or the bigger bus type that I had too. And then there was a van type. Now, granted, you can't really beat the whole. Well, it can't be more viewable when it's literally just an entire, almost completely like window in the front. That you can easily see anyone there. It's kind of hard not to just see where. I mean, you are touching the front end basically. The window is the front. Yeah, that kind of thing. Uh, so I felt like it was a lot easier of a design because it's just cheaper to manufacture and it works better and it's easier outright for anybody to kind of pick up and learn. Now, a lot of my motorcycles are a little different though. Like every opposed piston motorcycle I ever made was too fucking powerful. They're always like 1,500 horsey powers. You need 900 foot-pounds of torqueys at like only 3,000 RPM. I only just slightly toned it down so that way it would only get to 1,500 horsey power, even though I have it balanced at 28,000 RPM. And it weighs like next to nothing. Oh, great. Uh, This is the stupidest thing sometimes that I do that, because it's like, no one's gonna buy that. No, actually, a lot of people are gonna buy that. They'll just never use it. That's why I have the whole one stroke versus a two stroke versus a four stroke, and then there's like the Lemke cycle ultra efficiency power mode, which is its own terrifying thought process. You know, because that's my last name. Of course, I'm naming it after myself. You know what I mean? So, anyways, it's the other problem of, oh, but also by the way, we're not done by a long shot. Where, normally with the inlines, we have the crank that happens to be also a transmission kind of geary thing. Yeah, no, but what if I didn't care about that? What if I practically just stuck it to almost this is the smallest, tightest, best gearing box I could ever make. So it's effectively a bunch of cone gears that rest inside of a bunch of ring gears, and I mean ring as in like they're actually round like a ring. Okay. And then they use a bunch of balls that change in their gearing packs. Instead of gearing ratios, they're multiple CVTs, yes, but they're gearing ratios and gearing packs. So like multiple CVT packs here that spread out loads and then add gears together, and I have a high, medium, and low, and they switch basically off of that. And it's like, well, that's perfect for this because I effectively can just stick it into the inline and like this, well, this is a big round thing, that needs to be. And I'm like, yeah, I mean, it's the radiator itself, practically speaking. I'll just stick the radiator behind. Like, I need something to kind of defend with the axle, which, by the way, the axle, shockingly, is not what you think. And, like, I was eventually a person that turned it into, I'm just going to make it lay flat now. There's nothing that says I can't have it flat. Flat radios exist. I can have this flat. There's nothing that says I can't have this flat. And then I was like, I'm not really going to make this flat, am I? I'm going to turn this a little bit 45 degrees. No 90s and 180s here, 45s. We do the diagonals here in this place. So I did 45 diagonals. Like, here's the radiator. It's the stupid down direction, like radiator, and like that's structural. And then the 45 that goes up to the little arch of the tank, which is structural, the gas tank, that is. And then it's like, behold, the transmission, which is structural, which then goes to the differential independent link suspension like rear end of a all-wheel drive or 4x4 truck, which goes to the front then and into the rear. And that is indeed, you guessed it, that's attached to the radiator and the transmission and the exhaust manifold, which is the power delivery two-wheel drive axle driven, geared, multiple gearing ratio pack that spreads out the gears, the power from the engine, that is, to the gearing, and spreads it out over multiple gears in multiple places instead of having it be very inefficient and it'll wear out very quickly and it can't handle that with the materials. You can use standard materials instead of making them really, really hard and super, expensive. You can go with regular stuff, it's just that it's spread out over a lot more surface area and more gears as a result, and it is a still shiftable thing. It's just it shifts through gear packs. So think it'll start off smaller and then it'll go to a larger gear and then it's smaller to a larger gear. And they don't really overlap too much. There's slight overlap, but like I like to tune it such that you'll feel a little bit of a dip. Just to, like, it's a little bit too high. It's a little, but if it's, it can't do it, it'll go down and it'll go, oh, yeah, no, it's okay. I can do it. I can do it. So that way it's a lot easier for you to actually ride this with the 1500 horsey powers. I'm sure it's so difficult to make sure that you can power through. But it's like I had to, because then it was like, behold, the transmission goes directly to the differential that is effectively an all-wheel drive torque vectoring behemoth axle thing, but it's actually hollow and a smaller axle. So it's a hollow axle, but it's a smaller hollow axle with like effectively a double helix screw on the inside of the hollow, which that one was pretty fun to figure out how to do. You can effectively thread them through and then like you weld the stuff is essentially what it was, and then you balance it. But it makes it structurally way stronger. And then I fluted, of course, the axle because I'm weird like that. I was like, more weight savings and stronger. And then I did another double helical on the outside and more weight savings and stronger. And then I was like, is it possible to still hollow that double screw? I mean, it's connected with a hub. And so then I tried that, and it was like, no, it is possible. Actually, it's not that impossible, truthfully. And so then stronger and more weight savings and better. Same thing with the actual housing that has to have bearings and whatnot. Like it has to have at least 5 points of contact is usually how I like to do it, just because that's stronger. And so then it was like, right, well, stronger. And the actual housing itself, the inside and the outside, double helical and fluting channels. They gotta be cooled. It's got torque vectoring. You know what I mean? It's got a differential that means it goes 40 in the front and 60 in the rear at most. There's no 50-50 split here, but it can dynamically change that all the way up to 60, all the way up to 40. Right? It has, of course, on the actual housing, the vacuum with an air pressure spring. So there's a vacuum spring, there's a vacuum and then air pressure outside, and then there's fluid that's intermixed, like a heat exchanger. So they're not intermixed; they're separated, but they're right next to the fluid. You know, right? The fluid is right next to the air, anyways. But they're fluids, but they're different densities. But then blah blah blah. This is what it feels like. Anyways, that is the shock, all in one system. that's in each one of these. Behold also two ginormously sized, huge brake. Huge. So we're talking floating. We got the drilled and the slotted, and then the vented. We got the double piston, calipers, right? Or double calipers, three pistons, each one of them. So six total, either side. But that means 12, and then I've got actually 24 in the front, and then, you know, 12 in the rear, or I think 16 actually, because it's two and two in the rear. Big fat Mondo tires, you know, not like Grindhard Plumbing Co. I mean, those guys are big. I don't, I'm very adequately sized. Okay, Grindhard Plumbing Co. I don't need to go that hard. Jeez. Uh, but they are big. Okay, they are of the 25 to 33 inches total from like the tread to the other side of the tread diameter, with a sidewall of 3 to 5 inches. Okay, and then a width total, which is insane, up to 7 inches, or bare minimum 5. You don't get lower than 5. You're gonna have 5, or you're gonna have 7. That's it. Big boys, they're round, they're tiny little rims that are bead locked onto them, so that way they balloon. They really curve quite hard along the sidewall. That's why, no, but the sidewalls, they say that they're 5 inches. It's not 5 inches. That would be 10 inches, dude. Yeah, but it's ballooned. Okay, you don't understand. It's ballooned. You don't get it. Anyways, then steering's effectively another version of like it's on the other side of the differential axle thing. That's what steers the front, you know. It's a there's a left connection to the effectively only mounting point, which does have a plate, by the way, and it does actually have bars, like little bars that are there that connect everything, so that way they're quite stiff and rigid, but they're all structural. So, like, Formula One technology up in here, really thumbing my nose at people that say I can't do it. Anyways, it's just to make sure that there's a little bit more structural support. That's it. And then there's a plate there. I always have a plate there, but that's also why it's like 14 inches off the ground, the bottom of that skid plate. And why it's like, wait a second, you said 25 to 33 inches? You know what I mean? It's like, well, yeah, so if you wanted those ones, yes. I mean, they have like 40 somethings. Or they're ridiculous. They have huge tires. They're grind hard guys. I can't do that. I'm not gonna do that. I mean, you have decent tires. They were more checkerboard-ish, kind of like they got this nice little curve out, kind of like helical spiral thing kind of thing when it rotates really fast. It looks cool. But it's really just a checkerboard with like some grooves cut off onto the side that are diagonal, and then like some curved ones that intersect in between. You know what I mean? And then some nice chonkies on the side. So that way when you lean over, you still got like some decent, you know, contact patches, and still sidewall flex, right? And it's like I still got a shock and spring on both sides, for front and rear. And I got big, because you do have 1,500 horsey powers, 900 footies of the torques, which it's 28K, and I didn't say what the size of my engine was, my literage. You might have thought I could not do this. Twirls my mustache in evil looks and smiles. Anyways, behold, it's 777 cc's, point 277, or 777. It's triple sevens all around, but like they were willing to let me do that it's triple seven. No, it's triple. It's two sevens and an eight. He's like, no, it's not. It's nowhere close enough. It's not even nine. That's not real. No, you can't round up from that. Go away. Get out of here. And then I was debating with myself. They're probably gonna argue like that. So I'm gonna be like, well, if I put a seven after, three sevens after a two, that'll work somehow. Anyways, yeah, it's a weird number, but it's for the memes. I like the memes, the triple sevens. It's the good luck, you know what I mean? I get 12 of these bad boys, right? You know, I've got the three combustion zones, right? All those special numbers for certain people. I got a turbine, I got a compressor, you know what I mean? Got a nitrogen filter, a whole bunch of nice little, things to make sure it all works and lasts for a really long period of time. And it's got the cooling and got all the things. They are fiddly, I must admit, considering they're quite small. They are quite small. The reason why, like, this is not. I mean, I'm casting them, sure, but I'm also getting some of this forged because it's like, I can just CNC machine out some of these and just stamp some fucking steel and some aluminum and hypertectic, and they're all the right stuff, right? And just boom, and get this done a little bit faster and easier. And that's why I kind of created this modular engine block technology using CNC stuff on my YouTube channel, concept. I was like, because I need to fucking make this a lot easier. And then I did this so that way I just modularize this, make it really easy and stick a rotary 12 together that is a three pack. I mean, yeah, three packs that go off four times, and they alternate. So it'll start off from the center, and then it'll go to the outside, and then it'll go to center, and then it'll go to the outside, and then it'll go to center. So as a result, it's like a ridiculous amount of torque, but it's also a ridiculous amount of RPM. And at 3,000, it's like, yeah, no, but I mean, we're talking about like it's single stroke, you know what I mean? And I don't know, man. I don't, you know, I don't really want to tune any. Plus, I tone that down dramatically. Like I can maintain that 900 with a single stroke because of the injector thing that I'm doing, which gets stupid. Like at 3,000, it just keeps going up in RPM, and I can just keep pulling to 9, to then 15, to then 28K. So it's like, no, how about not Death Machine? You know what I mean? Especially when it's like, oh yeah, no, well, most of the weight all balances off of internal hollow suspension and pivoting points. Which the suspension on the outside is still there, right? Shock spring, all that. But it's like, oh right, when it loads up, I want it to actually, with the torque vector and everything else, actually bend forward. So I wanted to massively tilt you forward the moment you load up, and it's going to notice that based upon your throttle input and the torque it's generating and so on. So it then drops your front end and then tries to flatten you out as you're raked forward, right? And then it tries to massively stiffen up, and it basically turns all this weight past a certain point to pivot and then get balanced off of the front. So a way to think about that is there's this old school trick for tension where you'll have like a toothpick, a ruler, and some like a rubber band or a string, and shocker, a hammer. How is it staying so weirdly balanced and there's nothing holding it up, right? There's nothing, it's not anchored to anything, right? So then it's like, right, and that's center of gravity and mass. And effectively, that's what it's doing. Like most of the center of mass past a certain point is going to be moved forward very far forward. So that way it acts like it has a lot more leverage. It has to move up. And it'll do it also to the rear when you brake. So like, I can't lift up that rear because of course it's actually acting like it's way more mass, which is a good thing You're gonna want that, but it's also one of the reasons why, well, yes, I have downforce, I have amazing mechanical grip for all my vehicles that I've ever designed as concepts, and then it's like, same kinda thing for airplanes to a degree, but you can't really do it as much because, like, what's grip? And then it's like, right, w it's mostly control surface area stuff and, like, aerodynamic, fluid dynamic pressure differentials. So, like, wingtip over here, way higher amounts of lower pressure to induce a given type of roll, you know, versus something else, which, like, they do that, is just, like, a slightly different way of doing it, right? It's like, "No, no, 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 behold, actually, this is technically speaking bent forward slightly now on this other one, and this one is bent slightly, you know, upwards, and so now way more lift on one side versus the other, and yoink, suddenly happens. They all yoink. No, nobody expects this one trick from the airplane pilots. Yoink. It's still fun though. Um, that's what that was. But right. Uh, I had to develop something for like a bicycle. And then I was like, well, I'll just turn it into a motorcycle. Right. And it's like a motorcycle, like, holy crap, if you want that kind of power, you need to do a lot to make this not fail. You know? And then it's like, "Oh, right, well, no, but you see, I have more surface and all this other stuff for cooling, and I can definitely have a lot more safety. So what was that subcompact gonna make with this all-wheel drive, I'm sure?" And it's like, yeah, no, it's Torque Factory all-wheel drive." And it's like, "Yeah, well, I don't have to tone it back as much for what it's worth," which then turns it into, so 900 foot-pounds of torque, which is really around the 900 10-ish to 950, depends, you know. And then there's fuel. Like, this is regular unleaded gasoline. Then you get into nitromethanes and methanol and ethanols, which is not what this was doing. So, yeah, have fun. You want to go even harder. But I was like, I've already said no, no. I don't want to. That's scary. Get out of here. Nah, that's dangerous. Oh, you want me to? No, I'm good though. Uh, Most of the time, those are in the 7 to 8,000 horsepowers, which is just utterly lunatic levels of crazy. It seems like, um, from, oh right, I never said that. Well, that was 700, but it's just, this is the same thing for the subcompact, right? And it's like, right. Well, think 900 foot-pounds of torque. Let me just do the horsepower calculator again. Horsepower and torque calculator, because in my head, right? It's a 5252. Eh, I hate that number sometimes. Let's do 931. We'll do 931, 910 to 950, roughly. And then we'll do 28K is what that was, which is actually 28.5 something, but like you'll never hit 28.5, so get out of here. You 4,963.4, which now stands to reason why I'm getting like 7 to 8,000 horsey powers from those different fuels, because that tends to exponentiate itself for those kinds of things. But, like, there's lower friction than you think in terms of the coefficient, and the cooling's taken care of, which is fine, but that's also one of the reasons why it's like, "Yeah, you go way harder." No, you are massively dropping down that fucking torque, aren't you? Yes, hard. Yeah, no, super bad, just large amounts of no torque for you. Only when you need the torque do you get the torque. Which, I didn't talk about this or specify it, but the 3-pack, right, which is really technically 9 going off, right? which is one of the reasons why it's like, it's 777, right? There's like 3. Let's say 777 divided by 3. Let's do the basic calculator stuff here. Right. Yeah, so 777 divided by 3 is 259. Then you have to multiply that by 2, right? And then you have to add it after you divide it, or multiply it, sorry, by point 0.8. That's right. I can get point 0.8 of the center amount because there's still a rod there. So, that's all you get. So then that would be added to 414.4 plus 259 is effectively almost the entire engine going off in one single pack of 3. It's 673.4 cc's going off as a one kind of power stroke, but it's not technically one. It's spread out because of the way I offset them slightly, because that's the gearing stuff and the pivoting stuff, which means think about like they're connected at a single connection point on a crankshaft, right? And so that allows for it to then go boom, and then it rotates and boom, right? But then the others will just go off as normal, as a one altogether boom, right? Like a parallel versus a potato, which I like to call it, but otherwise known as a crankshaft that is crossplane, but it's a potato. It's the V twin, right? It's a potato, but boom, but boom, boom, boom. You know what I mean? Boom, 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 boom versus boom. Anyways, I slightly have the next one in line up a little bit during the next other one that was previous, and they kind of are. It's a combustion that goes boom, and then this one would be slightly behind boom, and so they're still technically going off at the same time, but that allows for all packs of 3 to have a 360 point of firing rotation of degrees. So like every degree, but it's like technically speaking, because that power stroke, there's always a power stroke that's happening during and providing torque. Okay, during the rotation. So it's a torque and then another torque and then torque and torque, and it never really stops. And now it's like an electric motor as a combustion engine. An electric motor gives you torque during all of its degrees, more or less, of rotation. Kind of the same thing, right? So I like to call it a big bang screamer. It's a big bang, but now it screams. Now here's the exhaust. Remember the whole like the turbine thing, right? Well, all of them are essentially going to go into the equivalent of an equal length tube header sort of thing, exhaust manifold. And what that means is they all travel, but then they all go to the turbine that's there, right? And then they all come out roughly, depending on where they're entering and they're given firing order, out at the same time. So it comes out like a constant turbine whine and a jet engine scream and a crackle, because that's the big bang part of a rocket engine. So it goes kind of thing. But you also have to understand the center part, which is boom, which 3 of them are going off. You also have 6 that are all going off, right? So, anyways, they're interspersed, but it's a whole thing. And that allows for it to be far more balanced than you think, but also far more powerful than you think, right? 673 times 4 for one singular rotation is 2,693.6 cc's effectively, which is one of the reasons why it's so more powerful than you might expect than a standard rotary. And 931 foot-pounds of torque sounds astronomically ridiculous, even with your nitrogen filter and compressors and all that, until you go, yes, no, except one single first pack of three is effectively almost the entire engine firing at once, and then I do it another three times, and then I do more than one rotation. That's right. That's one rotation, and then I will do that one rotation up to 28,000 times. Okay, which is a bit different. Let me just do that little multiplication thing here. So it's what was it? 26. Fucking damn it! My history. Give me my calculator. My history. Yeah, I know, right? I'll just do this real quick. I hit the AC and it just got rid of everything. It sucks. Should have wrote it down. I mean, just realized I need to divide 777 by 12, so give me a second instead. So this is already more than I thought. One, it's actually 1,126.65 cc's that goes off for 777 cc engine, but there's a reason for that because there's 6 outside going off for the 3 centers, which is 9. There's like that's cc's for each total cylinder. Give me a second. I know I went wrong. I multiplied by 3 for the 64.75, but I added that incorrect. The whole thing. Give me a second. Oh, that was a lot closer. That was my next one, but it's like wait. 505.05 now is what we got. I did it right this time. So it's 64.75 per each cylinder. That's times 3, and then I have the 0.8 of the 64.75, which gives me 51.8, and then I have 6 of those, so it's 310.8. Then I have to add 310.8 plus the times 3 of 64.75, which is 194.25, plus 310.8, which is 505.05, which is what goes off for one single moment of combustion. There's 4 of those, right? And then that has to be multiplied by 4, which is 2,020.2 cc's for one whole thing of a full power stroke of 360 degrees. And then I have to multiply that by 28,000, which is now basically the equivalent of these cc's in this many number of times in an RPM, as if it was that size of an engine that all went off at 1 RPM, which is, let's see, that's 3, so 56,565,600 cc's of an engine for one stroke of an, I'm sorry, for 1 RPM. Gotta get that 56.5 million cc liter engine going off at 1 RPM. Oh, goodness. Okay. It's like, no, it can never do that many torques. Okay, you could do that many torques. It could never do his rotating valves. He has no reason for springs. It can rotate as fast as it wants. Perfect air-fuel mixture. All the time he has port and direct injection. Yes. In pumping and the compression. Yeah, and the faster it goes, of course, the easier the compression gets. Because that's ram air. Which, yeah, I didn't state that, but yes, I do have ram air. Right. And it's because there's 4 combustions. So in one 360-degree rotation, you have the equivalent of, well, shouldn't it be all 777? Right? Yeah. But it's like, yeah, that's because it's cylinder. The cylinder amount bore in stroke is 777 0.2777 cc's, right? But because, yes, I am having 3 of them go off, which is not anywhere near that amount, okay? That is 64.75, which is 194.25 of the cc's from the center, because it's a post piston. But no, the outside is also going off, which is zero point 0.8 of each one of those bore and strokes, total amount. Because, of course, there's a thing there that's in the way and so on. And so I can only get 51.8, but I have 6 of those because there's the outside, right? There's an outside, there's a center, which is 1, and then the outside, that's 2 things compared to the center. I know that sounds weird. It's not. Think there's a bottom, and then there's a top, and then there's an empty cylinder in the center now. That's why there's 2 on the outside. Because there's an opposed piston, there's 2 pistons, right? Anyways, as a result of there now being twice the number than 3, that means, because that's how it has to balance itself off, right? For this 3 trick to go off, to happen the right way. So, like, if I combust 3, that means 3 on the outside have to combust as well. Which means I get 6 of those, which means I have 310.8 of those, which I have to add in, and that's for 1 combustion stroke. Which now then means it's like, oh, I somehow magically got more cc's. I didn't. There's no magicked it up at all. I'm using the same 7.2777 cc's, just differently. I'm using the outside and the center, right? Which effectively means they're rotating their combustion stroke and cycle such that the outside is while combusting at the same time. It's like I have 2 combustion zones going off, and then I have 1 in the center that is also going off. When you add them together, of course, you get 505.05, right? But because that's only 1, and then it rotates as it does this, that means I effectively multiply it by 4, and then it completes 1 whole rotation. That's right, in 360 degrees, it does that. Now, it's still going to, actually speaking, use only 777.2777 cc's. But because I'm using the outside and the inside, and I'm timing it appropriately, it gets to act like I'm using 3 different 777.2777 engines. I have 3 of them. I have the one in the center, and then I have the one on the top, and then I have the one at the bottom. There's a top, like a traditional standard inline, and then a non-traditional other inline that has a bottom combustion, and then I have an opposed piston traditional that has the center. That's why it's more efficient. That's why it acts like it has more actual literage than it does. Now, it's a workaround, kind of like hyperthreading. There's this core. Well, hyperthreading means I get it to act like it's 2 cores, and they call them threads. Behold the thread version of engines. That's right. Now, it's like he magicked up some bullshit. No, I didn't. I'll tell you the truth. I'm using only 777.2777 cc's. But because I'm using it this way and timing it this way, it acts like I have way more, which is perfect. And incredibly ingenious as a way, if I want to toot my own horn, to get around power constraints, which is the whole point of the engine. The whole point of the engine is to be highly efficient. it's in the 70% range. But that's also because it's doing a lot more work for a lot less energy because there's less friction, and effectively it's pushing more power. But granted, there is pumping losses here. All right, and there are frictional losses still because, of course, the gear and axle and bearings are still there. Well, I can combine quite a few of them as best I can, then that's another type of rotating type of thing and so on. I'm going to move off of that, mostly because that's like a type of ring gear, like they already have for timing that thing. But like that rotates off of that, and then that will rotate the ring gear, which will then connect to the main turbine. But then that's a different type of thing also, as those have to have a gear that goes directly to the crank as well. Right. So it's like it's there. That gear will then also attach to the crank, but then like those turbines also have to attach. But that's also why, behold, it's roundish with some balls around for the turbine, which then now means it has a CVT and changeable gearing to add to when necessary, and it's not having to add it to the axle that goes to the hollow part of the axle in the center to the compressor at the front. Yeah, I know. It's like you have to keep all of this in your head like I do. That's something I keep all in my head at once. It's not hard for me. I can literally see it moving like it's nothing. Now, how did you do that? Well, I sat still and I thought really hard because I can't move lines on a screen like CAD. CAD bothers me. Everything about CAD bothers the fuck out of me. But behold my brain. Yes, look at the spinny thing inside of it. Yes, I shall zoom in hence. Way harder than anyone else can. I shall look at this part moving over here to there to this to that to that to this to this. It's looking like it's working. I'm seeing it work. There's a lot of working happening here. I like this. Anyways, I want to get to the end of this. The RAM part is much easier to do when it's like, the kind of intake manifold that it is, right? And then that's a, four-piece separated. So it's like, remember the three? It's like separated into four parts, right? The intake comes in as four parts, but then that gets separated into three zones. Effectively, it goes from one big and then it separates into four, and then from that four it'll go off into three more. That way it effectively just moves to the fastest position for the lowest amount, which is a vacuum and valving pressure differential. And all that really means is like as there's lower pressure here as it needs it, it'll then more easily go there. And then because there's already rotating massive airflow that's there, it'll more easily also still continue doing that and get even better efficiency that way. That way it can reduce air pumping losses for compressing, right? And then same thing for, well, I have a bunch of oil being pumped around, but it's like, yeah, no, I also have pistons that I need to move. So it's like, screw this. The pistons are the oil pump. I'm just going to leave it alone. Like, the pistons are obviously the oil pump. I'm done. I don't want to fuck around with this. This is way easier. And they're also going to be able to help with, remember the pivot part? Like that, and then the ring has to move and the crank, right? That's our coolant pump. Right? Simple stuff. We got to keep it simple and compact as fuck. Right? So like that's going to be the coolant, and that'll move from in towards the front and then towards the rear. Right? It'll start at the bottom and it'll come out at the top. Simple stuff. But I also have two, so I'll have it one on one side and one on the other, so that way, but they're lower down in case one of them fails. Now I don't have to worry. They'll still move it, evenly, but that's redundancy, and I love redundancy because redundancy, if something fails, well, it'll still keep working, and I'll take that, right? And then same thing for the manifold and the exhaust manifold. So all of that is a structural part of the engine block, right? Like, you have to literally do that to make it work. It won't work without it. Same thing for the turbine, which is another part of that, right? And then all of it now is able to be from this, you think this is going to be so massive, to shrink and squeeze in. The pivoting thing now becomes much easier for you to probably conceptualize because, well, effectively, it's a part of right next to where the manifold is, right? It's like the manifold has to go in between where the pivoting thing is. That's what has to happen now, right? And so, like, the engine block, manifold, and intake manifold for exhaust and intake are all going to fit in where they really can only fit in. And as a result, it's like, no, it went from like this big, huge, humongous air, fin cooling thing to nope, 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 and shrink. Of course, they're still there, right? I still have to have the bristling out lower pressure air cooling fins, but they're of course going to stick out, and they are more of a thermal siphony, vapor chambery, heat sink kind of fin thing that sticks out. And instead of needing these valve covers, well, they can just be on the towards the top or the bottom, or in between the manifold towards the center kind of thing, and still ultimately produce that cooling that you're looking for, while still having that compressor towards the front, still have the manifold right there. And so when you think about it, it's like it's going to be this big, huge manifold for the exhaust turbine area, and it's like, no, that's shrank massively because that's already a way larger, you know, outright radius, which means more fins and blade angle, which then eventually goes to a smaller. So it goes from an outwards to a smaller. So take it outward trajectory, take it towards a central trajectory, which then has to have it all come out, right? And it has to all come out bifurcational. I do bifurcation. So it comes in wherever it is. It's going to take all an equal kind of roughly path in. And by roughly, I mean we're talking millimeters. So I don't think there's much of a difference there, but I'm going to move on to it, then splits off to two. Two off to the sides of where the actual axle that will connect, which because those are structural, they then get separated to this is how you connect the transmission to your car, your plane, or your motorcycle. Remember the CVT thing I talked about? That means you can have much higher torque and you can dynamically change the prop rotational speed. But that's also something where I was like, what if I had a counter rotating, well, screw counter rotating. But if I had like, an offset prop, let's say it was four props in the front and then another four behind, they rotated at the same thing, but, same speed, but they changed their pitch and blade angle interdependently of each other. And they also happen to do this other cool thing where they can change their outright total, I guess, length because they can slide open. They can slide on themselves from internally. They can slide a little bit further out, so they can be a little bit taller or a little bit shorter. And if you know anything about props, then it's like, well, the front can now rotate faster and the rear can rotate slower because that's right, they can interdependently rotate. So it's like they don't just have changing prop sizes and prop angles, meaning blade angles, they can rotate while still the same direction at different rotational speeds. And it's like, right. Now you think that's not a good thing, but that actually does the very thing that you're looking for. It literally removes the howling scream of counter rotating props or way too fast prop, uh, wingtip vortices effectively. Because the vortice will then get fed into the prop behind it. Because the prop behind it is built and designed to take that wingtip vortice and slowly extend it, like we do with delta and swept back wings and tapered wings too, at that, to effectively extend it as far as it can until eventually it just sort of turns into a type of thrust, as it'll create a combinational vortex to the next one as it trails off that's coming up, right? Which is perfect. You're gonna love that because it removes the scream howl, makes it silent, and makes it way more efficient because it effectively spreads that out and produces more thrust, as it'll create a Bernoulli's principle and Venturi system kind of effect as a result, making the props more efficient even if they aren't counter rotating. They're just spinning at different speeds, and they are, of course, at different angles and at different lengths to achieve this effect. Now, granted, my way of doing it was that they actually bent. Okay, so like the prop itself is flexible, and there's a hollow core. It's a vacuum, and it can extend out. Right, there's a fluid that's attached to a piston that hydraulically then bends it inwards or outwards, concave, convex. But then we still have standard rotation, and it still has a standard given type of blade angle and pitch and chord amount. But the chord amount is different, kind of like turbuckle, and then waveguides like feathers trailing. They're on there, yes, but there's also holes in these props, specifically to facilitate these effects, sort of like a toroidal. They're lighter weight, they happen to spin in such a way that they trail off that supersonic shockwave into another shockwave, into another shockwave, into more pulled air that is there, that then delays the shockwave as it expands the shockwave because there's now more air it has to push, thus removing the shockwave and then putting it into a wider blade of a longer type that's traveling slower, making it more efficient, that is now bent and curved and then shaped to trail it off, thus making it be able to spin even faster and spread out even more amounts of thrust, making it even more efficient, doing the same thing. That makes it so different altitudes can be achieved more efficiently at much higher velocities for an engine like a Radial like mine. I now have the ability to go much higher altitude. That you'll need a pressurized cabin from your Cessna while you travel supersonic speeds. To be fair, the answer is yes, you could do that. But also, the answer is you need swept back wings and you need them to be tapered if you do that because that's dangerous. So don't maybe do that. But the answer is still a turbuckle front with the little channels. That's a different type of cooling, and then that's a type of way of sweeping it back towards the tip, as that's your leading front end change that will be able to be bolted on effectively and made structurally sound. And then you'll be able to have the waveguide ailerons be throughout the entire length of the wing. And then you can have a piece that is like an aileron, but it's really kind of like more like a diaphragm. It's a really taut type of strong fabric that you then are able to pull a string and or a hydraulic pressure line. I like redundancy. That can change its shape, thus giving you the yoink effect twist that you thought I couldn't do for cheap and lightweight amounts of effort and fuel savings. Same thing where the engine kind of acts like it's a turbuckle where the props are because it has to stick out a little bit to capture some air, and then the in between then allows for it to more smoothly transition to where the wings are, delaying any shock wave, allowing for you to then shape the rear such that it becomes more teardrop like. Now, the air is not traveling supersonic speeds, which is fine, because you don't need faster, much more so than the outright speed you're traveling. Think equal and opposite air resistance and so on. At higher altitudes, it becomes far more efficient. So, what that means is, because of the size of this, I can have it such that it's a lot more air flow, but it's also traveling very much into the Mach 2 and or even up to 5 velocity. But to be fair, people going Mach 15 or 12 or whatever they did have like way faster amounts of uh, velocity of those gases than they're traveling. So I don't think that that's really necessary to think about in terms of this, because that's kind of irrelevant. It's like, look at my Mach 32 velocity of gas, my thrust. I'm like, uh-huh. Going Mach 12, huh? Yeah. Still, that's really fast, but it just seems kind of hard to achieve that. I'm gonna just stick with like props. Seems difficult to do that, especially when this is effectively like kind of the transmission type that I'm talking about. So it's like this is this one, and then if I move this forward, I move that back. That's like a transmission gearing ratio, right? And like that's prop speed, that's bite angle, that's length, right? And that's twist and so on for the props. And that's like total rotational speed, depending on it's like high versus low gears for each one of them, right? So it can automatically do that. Or my initial design was mostly based upon an altitude sensor and cruising altitude and trying to maintain it based upon a gear pack that you're in, which means it'll use the least amount of engine RPM to achieve that, right, for most efficiency. But that does mean if you're in like first gear, it might scream up to 28K. So probably don't do that, right? You probably don't need that. Just a suggestion, but maybe you do. That also begs the question as to why you're doing that, but far be it from me to complain about that. But at the other side of it, it's a stick lever. That's right. You have to press in a clutch in your plane to change your gears. Now, you can automatically do that. I just didn't do that because I think it's super cool to change gears and altitude like I'm in a race car with a gear stick lever, you know what I mean? Like, yeah, I'm climbing, I'm climbing. Yeah, you gotta get that suicide shifter when you do your dog fights. Have you ever heard of like the money gear shift? Look at you. Look at you suddenly going up to 28K. Broke your friggin' props, didn't you? uh, Still though, um, it's not altogether perfect like that because while I can make it automatic pretty easily, And it's not quite as simple because, of course, bite and pitch and all that for those props, and that's not just RPM, is a lot more important. So, um, that is to say, your yoke is going to have like brake bias buttons, on Formula One and stuff. It's effectively the same thing. It's going to be pitch bias and like angle stuff, effectively. Granted, we're talking like in this altitude range, in this RPM range, and in this airspeed, you should probably have these things. But you're allowed to do what you want. So that kind of thing. So that's what that would be. Um, and then that's why my radial 12 opposed piston. Man, I'm gonna have to re. Anyways, um, three combustion chamber, which would be cmb-c OP, I believe is what it is. I'm gonna have to rename this. So clearly, it was just named my Radial 12 OP engine right now. I'm gonna change that later. So that's a little. If you got an hour and 40 minutes in, you know that I changed the name. So there's that of what I named this. Anyways, behold the new radio that will power all of the aircraft and be hyper fuel efficient and so cool. You cannot not do it. Ooh hoo hoo. It shall be in all of the cars and planes and trains and the motorcycles. Why wouldn't you have it? Radios are back in style. Oh yes. Oh yeah. Anyways, all right. This is my tagline. Sometimes it's a good, just being cheeky. To sometimes I'm being mad and I'm angry at you. This one's cheeky. Suck my dick and balls. Hit that like and subscribe. Hit that notification and please share. See you later.